Okay, welcome back to the 2023 Algebra 2 Final Exam Review. In this video, we're going to discuss Section 6, where we name polynomials by their degree. So the first thing that we want to revisit for a second is what polynomials are and what common polynomials look like. So this chart I got directly from your textbook, but to reiterate, because we've already talked about these a lot, so we just need to talk about how the degree relates to the type, and generally what they look like in standard form. So when we have a 0th degree polynomial, it's just a constant. And a constant, remember, it's just any number. It can be like a 2 or 3, a -5, even decimals or fractions, any real number. And it's just f of x is equal to some number without a variable. There's no x, and it's not raised to a power or anything. It's just a number. Our first degree polynomials we call a linear function, and those are the ones that we see mostly in Algebra 1 at the beginning of this course in the first semester. It was something like a number times x plus another number. And this number here could be 0. It's important that what we call the leading coefficient, so this a1 in this case, is not 0, or else it's not a linear function anymore. It'd be a constant, because 0 times x is just going to be 0, and we'd just be left with a sub-zero. And then in chapter 4, we started seeing second degree polynomials, which we call them quadratics. And so when they're in standard form, we would see that usually we saw this more familiarly as ax squared plus bx plus c. But this a sub 2 corresponds to a here, a sub 1 corresponds to b, a sub 0 corresponds to c. And so this was our quadratic polynomial. And this is also in standard form. Remember, standard form is when we have the highest power of x, or whatever variable we're using, and then they're in descending order. So we have an x squared. This is implicitly an x to the first, because anything to the first power is itself, so we don't really need to write that 1 there. And even here, we implicitly have an x to the power of 0, but anything to the 0th power is 1, so it would be c times x to the 0th, which is just c times 1. Anything times 1 is itself, so it's just c. So we don't need to have x to the first here, or x to the 0th. We can just have x and leave off a variable entirely here. But our our third degree polynomials we call cubics, and so it's a number times x to the third, a number times x to the second, a number times x, and then plus a number or minus a number, it doesn't really matter. Our fourth degree polynomials we call quartic polynomials, and a number x to the fourth, number x to the third, number x to the second, number x plus a number. Notice again, all the exponents here are in descending order, so it becomes probably clear by second or third degree polynomials. We have a second, first, 0th, third, second, first, 0th, fourth, third, second, first, 0th. So if our polynomials are going to be in standard form, they have to be in descending order. And it's also easiest to identify what kind of polynomial we have, because we just have to look at whatever our first term is and look at its this exponent here. So since this one is a power of 4, its degree is 4, and we call it a quartic polynomial because the type is determined by the highest power of x that we have. The next one we have is degree 5. We call those quintic polynomials. And the highest power of x here is a 5. And then we have 4, 3, 2, 1, 0. Something to note is that we can have these constants except for the leading coefficient here, but the coefficients that we have for a sub 4, a sub 3, any of these over to the right, these coefficients can be 0. However, it's only the leading one that can't be. So you don't have to worry about maybe there being like a 6th-degree polynomial, but you don't see a power of x because the coefficient is 0. You don't have to worry about that. It's just whatever the highest power of x we have, that's going to tell us the type that we have. So let's look at now the assignment that we have. Something to also note before I get started on that, something to note about that is that for polynomials, they must have whole number exponents. So as mentioned up here, like we actually have an exponent of 1 and an exponent of 0 over here. But we have to have whole number exponents. So 0, 1, 2, 3, off for as many numbers as we need. And they must have real number coefficients. So we can't have any complex numbers for our coefficients here. So you can't have something like 3i x squared. This has to be a whole number here. So this I makes it not a polynomial, at least for our purposes. So now we're ready to look at the assignment. And the first 6 are already in standard form. So for number 61, we have negative 9p cubed plus 10p minus 4. And so we see that it's already in standard form because our powers of, in this case, p, are in descending order. So we have a 3, implicitly a 1 right here, and then p to the power of 0 right here. So it's already in standard form, and in order to identify the type that it is, and we want to name it, we just have to identify what this power of p is. So this is a 3. So we say that this is a cubic polynomial. And often you don't even hear mathematicians or teachers say that it's a cubic polynomial. Normally just say that it's cubic. For number 62, we have 6v to the 6th minus 2v to the 4th minus 6v squared plus 7. And if we look back at our chart here, I don't have a name for degree 6. And so as far as I'm aware, there isn't actually a name for it for the type. After degree 5, we usually just call them whatever the degree is. So like in this case, we have the highest power of our variable v here as being a 6, and we just call it a 6th degree polynomial. So after degree 5, they actually lose the special names. You start running out of special names after degree 5. So really the only names that you should have to know are constant, linear, quadratic, cubic, quartic, and quintic, and associate them with 0, 1, 2, 3, 4, and 5. For 6 on, you can just call it a 6th degree polynomial, or a 7th degree polynomial, or an 81st degree polynomial. No special name after that, so you can be pretty sure that these are the only names you'll have to memorize for naming polynomials. For number 63, we have negative 4x. So we only have an x here, and implicitly it's a 1st degree, or x to the 1st power. So we call our 1st degree polynomials linear. For 64, we have 7n to the 5th plus 7n to the 3rd minus 3n squared plus 4n plus 4. We see that this is still in standard form. We have to the power of 5, 3, 2, 1, 0. And our highest power of our variable in here is 5. And so we call this a quintic polynomial. For 65, we have 9n to the fourth plus n cubed minus 10n squared. And so we have, still in standard form, 4, 3, and 2. Highest power of n here, our variable, is 4. So we call this a quartic polynomial. For number 66, we have 9x squared plus 3. Our highest power of x is 2. Implicitly, we have x to the power of 0 over here for the 3. But power of 2 gives us a quadratic. For number 67, now we have negative 8b minus 4b squared. So with all of the ones before this, we were able to just look at the first term, and we only had one term there, but we were able to just look at the first term and tell what kind of polynomial we had. We had a 3 here, so cubic. We had a 6 here. Couldn't quite read my handwriting for a second. So we had a 6-degree polynomial. 1 gave us linear, 5 gave us quintic, 4 gave us quartic, 2 gave us quadratic. But now, number 67 is not in standard form. We have this negative 8b, which is to the first power here implicitly, but then we have minus 4b to the second. And the term that's going to tell us what kind of polynomial we have is given by the term with the highest power of our variable. So in this one, it is a 2. Now, if we rewrite this in standard form and rearrange it as negative 4b squared minus 8b, now it's in standard form because it's in the powers are in descending order. We have a 2 and now a 1. And now the leading term tells us that it's a quadratic, but we don't need to rearrange it to be able to tell what it is. We just need to identify the highest power. It's just nice when they're in standard form because it's pretty easy to pick out for us and we don't have to rifle through all of our terms and check each one, which one is the highest power that I see. But that being said, this is a quadratic. And for all of these, even though for your review you're not required to write each one in standard form, I'll go ahead and write them in standard form because it's just something that is good for you to see. The next one we have is for number 68. This is 7m to the fourth plus 6m to the fifth minus 5. And we notice that this is not in standard form because this is a 4, then a 5, but then implicitly to m to the first here. So if we rearrange this, we can say that this is 6m to the fifth, so start with the highest power of our variable. Next we write 7m to the fourth, and then minus 5. And the 5 is really the only part we cared about to identify it. And we say that this is a quintic polynomial. Couldn't spell for a second there. All right, for the next one, we have 5n cubed plus 5n plus 7. This one actually is already in standard form. We have a 3, implicitly a 1 here, and then we have to the zeroth here. Our 3 is our highest power of n, and so this is going to be a cubic. For number 70, we have negative 5x to the fourth. We only have one term here. That's nice. That was easy. So this is to the power of 4. So this is a quartic polynomial. For number 71, this is a long one. We have negative 9x to the sixth plus 3x to the fourth minus 9x to the second plus 5x to the third, minus 3x to the fifth, minus 4x. So we have a lot of terms here, and we see that it is not in standard form because we have 6, and then 4, and 2, and this is good so far, but then we go to 3, and then to 5, and then to 1, so it's not in descending order. So it's not in standard form. However, looking at all of our exponents, we can tell what kind of polynomial this is. We have a 6 here. This is the highest exponent we have. And so we can say already that this is a 6th degree polynomial. But if we want to write this in standard form, we have negative 9x to the 6th. And now let's see if we have any x to the 5th terms. And we have that here. We have negative 3x to the 5th. And I'll just cross these out so we can keep track of them. Now we're hunting down for 4th. We see that right here. So plus 3x to the 4th. And to the 3rd, we have over here plus 5x to the 3rd. Hunt down for 2nd, we have negative 9x to the 2nd. And then to the 1st here, we have minus 4x. So now this is in standard form. We have 6, 5, 4, 3, 2, 1, and then a constant of 0. And like I said before, we could already identify it from up here that this was a 6th degree polynomial. It doesn't have a special name, so we can just say that it's 6th degree polynomial. And lastly, for number 72, we have 6m. And anytime we see just a variable without an exponent, we know that that means it is to the power of 1, and that means that we have a linear polynomial. And so that wraps up this video. I hope that was pretty straightforward for you. This is not covered explicitly on your exam, but I thought it was worth going over and reviewing, and hence why I included it on your review. But that's all I have for you in this video, so thank you for watching.